Do you have any questions from the homework? 7.1. Tell me. 41. Oops. Okay. Tell me what you thought on that one, Emma.
My problem was mostly with finding the
It was one of the ones that I said find the exact value. There were like 3. The rest of them said find an approximate value, which means you can just punch the integral on the calculator. This one said find the exact answer. Did you look to see if it crossed the x-axis or if there was anything you had to consider?
It does, but because of the inequality, it's fine.
So not between 0 and 1.
Correct.
Between 0 and 1, is it all above the x-axis or all below? Above.
Like my integral itself is fine, but evaluating it's fine.
Okay. All right. Let's see then. If we want the area under this curve bounded by the x-axis and the 2 vertical lines x equals 0 and x equals 1, then we look at the graph, make sure that it's above the x-axis, and if it is, we can integrate from 0 to 1 x e to the negative x squared dx. So, what were you thinking u would be?
My first thing was to make e to the x squared in the denominator u and basically had an fraction form.
Mm-hmm.
But that didn't really lead anywhere.
Yeah, if you let u be the whole e to the negative x squared, then you have to have another e in the derivative of that, and you don't have another e, and there's no way to get another e in there. So it can't be the whole e to the negative x squared. My first instinct would be it's the negative x squared, especially since you have an x right there.
Yeah, it could be that I just, because I tried that too, and
Okay.
just because I was tired that part didn't work.
Yeah, that's possible.
So,
That's
let's
possible.
see.
All right, so if you let u be negative x squared, then du is negative 2x dx. And we have the x and we have the dx, we just need the negative 2. And we can get that if we put e to the u and then du.
I think when I wrote e to the u,
Mm-hmm.
I was like, oh, I need another e to the u and then du, and that's it.
Yeah. Excuse me. It helps me to write down my u and my du. I just lose track of things in my head. But if u is just the negative x squared, then the du is not going to have another e in it. So does that take care of you? You could have negative 1/2 times the antiderivative of e to the u du is just e to the u, and then evaluate that at 0 and 1. All right, anything else from 7.1? Going once, going twice. All right, let's go to 8.1. I believe that you know all of the integration rules that you're going to know this semester. There are some other things to memorize, but not integration rules. And they're all in this lovely box on page 516. And they're on the practice test. The back page of the practice test has the 20 integration formulas you're supposed to know, and print that off as many times as you need to make sure that you have memorized the ones you need to know. Honestly, I still peek at arc tangent, but arc sine and arc secant. I know what the integrand looks like, but I forget which one of them has a coefficient of 1 over a. Just looking at it, there's no good reason that that's not sticking in my brain other than the fact that I'm 53. So y'all shouldn't have a problem at all with your young brains. All right. Let's just jump on some examples. Oh, one other thing. This is really good. On page 519, they have, this is your toolbox. Now, we don't have every one of these things in our toolbox yet. I think there are 2 that we haven't seen. We have seen that we could FOIL out something. But we know we can integrate term by term. So if we can write something as a sum or difference of terms, we can integrate it. We can't integrate a product. We don't have a product rule for integration yet. But right now, if we can write something as terms, we can integrate it. So FOIL that out if you need to, or split the numerator and integrate it term by term, or we talk about completing the square, and very often that's for your inverse trigonometric functions. If we have a fraction that either the degrees are the same in both the numerator and denominator, or the degree is higher in the numerator than the denominator, maybe we need to do long division so that we can integrate term by term. We've talked about sometimes we have to add something and subtract something in the numerator to get what we need. So the only 2 things that we haven't talked about using Pythagorean identities, but really, I feel like we've used those some. Yeah, I feel like we would think of that. This one would never cross my mind. If I was trying to integrate 1 plus sine x, and I thought, well, let u be the whole denominator, then there wouldn't have to be a cosine x in the numerator. Or even if I just let u be sine x, there would have to be a cosine x in the numerator. So my first instinct is, well, I just can't do that. And it never would have occurred to me if I hadn't had a teacher or a book say, hey, here's another tool for your toolbox. Multiply by the Pythagorean conjugate. Okay. Why does that help? Well, if my denominator is 1 plus sine x, and I multiply the whole fraction by 1 minus sine x over 1 minus sine x, the denominator becomes a Pythagorean identity. And if I have a Pythagorean identity, I can put a single term in the denominator, and then I can split it if I need to. I can split fractions with a monomial denominator, and so multiplying by the Pythagorean conjugate is the way to get that denominator to be monomial. That, honestly, is the last thing that would occur to me. I would try all that other stuff first. But in all the integrating we do, it's going to be, remember what's in your toolbox. And by the way, have you printed the practice test yet? On the front page, I have tools for integration. It doesn't have these last tools because we don't really get to them until 8.1. And I won't put one on the test that you have to multiply by the Pythagorean conjugate. But be aware that these are going to be 2 new tools in your toolbox when we get past test 1. All right, so I have circled some good-looking ones on page 520. You have that? You need me to wait a minute?
I got it.
Got it? Okay. That's page 519 in your book if you need it. And here's what I have circled. There's often more than one way you can do these problems, but you've got to try something. And very often it's going to involve a substitution, either formal or informal. So tell me what you're thinking. Right after I did calculus 2 at 7 o'clock in the morning. What's your next thought?
The denominators here.
Go ahead. What do you
We
think?
need a 2x.
Okay, so I think the whole denominator being u, looking toward this being a logarithmic integral, is not going to work because I don't have a 2x in the numerator. It's a reasonable first thing to think of. So what else do we have in the toolbox?
Maybe you can do it this way. Well, there's no b's.
Right, but that's a reasonable thing to think. Look at my list here. Does it look like any of these? It's arctangent. Where? Yeah? Where A is 1 and U is what? Is the x. And then U is dx. So that's just arctangent's 1 over A, which is 1, arctangent of U over A, which is just x, plus a constant. So recognizing is the hard part, not doing it, just recognizing. And I would probably, if I were taking this test, I would have a few things that I tend to forget written at the top of my paper before I begin. Definitely the formulas for arc, sine, arctangent, arcsecant. I believe I have the trig ones now, but if I was in doubt, I'd write them down. What about number 24? Give me any idea you have. Try something.
Can we divide the 12 by 11?
We could,
The same.
yeah, the numerator and denominator are the same. So what would happen if I tried to divide x plus 4 into 3x? I guess I could put a plus 0 on there. Then what?
It would just be 3 and
Yeah, x goes with 3x 3 times. 3 times x is 3x. 3 times 4 is 12. Change both sides, and you have signs, not sides, and you have a remainder of negative 12. So I could write that as 3 plus negative 12 over x plus 4. Oh, that's pretty cool. I'm going to do it that way because that's what you thought of, and then I'm going to tell you what I thought of. And we should get the same answer either way. I'm going to double check if I combine these, because I'm OCD about checking. I'd have to multiply 3 times x plus 4. That'd give us 3x plus 12. And when I subtracted that 12, I'd be back to the 3x I started with. So my division's right. And I'm going to rewrite this integral as 3 plus negative 12 over x plus 4 dx. And then I could integrate it term by term. What's the antiderivative of 3? 3x. And if I can go ahead and integrate the second term, I will. If I don't want to do too much thinking at once, I would probably just say Well, I could bring the negative 12 out in front of the integral and just integrate 1 over x plus 4 dx. Yes, sir.
So here in 3, we're negative. Since you applied x plus 4 times 3, but you wrote down negative 3x minus 12.
Oh, this, in my long division, after you multiply, the next step is subtract. And when you subtract, you distribute that negative 1. Okay. So far, so good? Is that equivalent to the line above it? Yeah? So maybe I'll get half credit. What's the antiderivative of 1 over x plus 4? Yeah, that's 1 over u. Yeah, that's 1 over u, and the derivative of u would just be dx. So 3x minus 12 times the absolute value of x plus 4 plus a constant. Minus 40. If you leave off an absolute value or a constant, don't even come back. You fail. I'm kidding. Poor Michaela's going to hear that on tape. Oh, or natural law. If you leave out the LN, you fail. Jeez. I think I said it and didn't write it. There you go. All right, 34.
Or you want to show it alternately do that?
Oh, yeah. I was going to tell you. Oh, no. I'm just going to say that the other thing I could have done with number 24, the first thing that would have occurred to me was to say that if u is x plus 4, then du is just dx, but I have an unaccounted for x. So what could I put in place of that unaccounted for x? U minus 4. If u is x plus 4, then x is u minus 4. And so I could have called that integrand 3, I'm just going to bring 3 out front, 3 times u minus 4 for that x, and then what for x plus 4 in the denominator? How would that be? If I don't want to write it as a fraction, it would be u to the negative 1 du, because du is the same as dx. And then I could distribute that u to the negative 1. It would be u to the 0, which is 1, minus 4u to the negative 1. Which would be the antiderivative of 1 is x, and the antiderivative of negative 4u to the negative 1 is negative 4 natural log of u. That should be u since I'm going to use it. Yes. I keep failing. So far so good. So I would have 3 times x plus 4 minus 4 times natural log of absolute value of x plus 4. And then would that be equivalent to this if I cleaned it? Oh, look, this is a good thing that happened. Let me show you something. If I distribute that 3, I have 3x plus 12 minus 12 natural log of absolute value of x plus 4 plus c, and then I go, hold on, This one didn't have a plus 12, but this one did. That's two very different looking answers. What's the deal with that? I freaked out the first time this happened when I taught this class. I called Miss Denton, woke her up. Why is my answer wrong? The back of the book has this. Why is my answer wrong? And she said, your answer's not wrong. It's just different because 12 plus a constant is still a constant. So we don't know what that constant is. This constant is this constant is 12 more than this constant, but they're both constants. Yes, that freaked me out for a minute because until last spring, I hadn't seen Cal 2 in 30 years. All right, so what about 34? Try something. I could definitely do that. My first instinct is pretty much always, can you just be the denominator? Could you just be the denominator in this one? No, because du would have to have another e to the x in it. All right, so e to the x. Okay, well, let's write it down. I don't know if it'll work or not, but we'll write it on pencil. And I'm knocking out. So 4 times the antiderivative of 3 minus e to the x to the negative 1. That's when I think, well, that would just be natural log of absolute value of 3 minus e to the x. If I had another e to the x with the dx. So writing it this way didn't really help me because I realize I have the same problem now that I had right here. Yeah, but I mean, if you think it'll help your eyeballs, then write it differently. I have a wild idea. I'm wondering if I can beam it to you. Just anything we can try. My beaming quartz. I can honestly tell you that this would not have occurred to me. I'm going to see if this is what I did. That's not. It would not have occurred to me without years of practice. Yeah, never would have occurred to me. So, don't worry that it's not occurring to you. However, I don't think this is helpful to me. This is just another tool in your toolbox. You could multiply by the conjugate. You absolutely could. All you really need to multiply by, let me see if I can give you a hint for when to look out for this. Stop trying to avoid learning, Sharon. No. We haven't practiced this enough. I don't think e to the 2x would help me, but I think e to the 0 might help me. How could I, when I multiplied, how could I get an e to the 0 if I was multiplying by what? Okay, there is no reason that should occur to you before you've ever seen it. But look what a fabulous thing it does when you know that that's a tool in your toolbox. And yes, your toolbox is getting quite full. You would have e to the negative x over 3e to the negative x minus what? 1, because you'd have e to the 0. Now that doesn't look better. Why is that better? Or why is that helpful? The problem here was we had an e to the x in the denominator and we didn't have an e to the x in the numerator. If u is just negative x, we have an e to the u in the denominator and we have an e to the u in the numerator. So maybe now we could let u be, let me think, if we let u be the whole denominator, I'm not going to write this down yet. If we let u be the whole denominator, what would du be? I'm going to write it down because I can't see it unless I write it down. I'm just going to mark it out. If that's u, what's du? Do we have anything close to that in the numerator? Yeah. If we just had, we could call that denominator now u to the negative 1. I think I can get by without doing a formal substitution. There's u to the 1, negative 1, as long as I have du beside it. And du beside it would be negative 3 e to the negative x dx. Is that equivalent to the line above it? Not unless I do what? Or divide by negative 3, same thing. Is that equivalent to the line above it? Oh, sorry. Is that equivalent to the line above it? 4. There's the 4. There's the positive 1, e to the negative x in the numerator, that in the denominator, and just double check one more time. If this is e to the u, is this du right beside it? Yes, it is. So now, no matter how scary that looks, it's just the antiderivative of 1 over u du. What's the antiderivative of 1 over u du? Minus 40. That's one thing I love about one of our former English teachers. She finally retired. People call her Satan. But if you made, she had a scale of how much a misspelling counts and how much a sentence fragment counts. And if you got to 0 and still made mistakes, you could get back a negative on you. You think it's hard to pull up a 0, you should try to pull up a negative 50.
Don't give me a challenge.
Okay, so that employed a trick, a tool that I had not seen before, but I'm just sticking it in my toolbox. I remember that that's there.
Is there any way to simplify that? Because I don't like that there's an E inside one.
Yeah, I see why that's bothering you, but you can't distribute natural log as though it were a constant. You could say, I could write the difference of two logs as a log of a quotient, but I don't have the difference of two logs. I just have log of one thing with my computer. All right. We're doing pretty well. I have 4 more circles. Let's see, 36.
No, it's like, what?
What is tangent of x times the natural log of cosine x dx? You're just going to have to try something. You're going to have to have an idea, try it. If it doesn't work, erase it and try something else. But I don't think you're going to stare at it. Well, at least I can't stare at it until the answer just appears. It doesn't work for me.
I kind of want to rewrite the natural log and see if I can multiply the tangent log.
Okay, how do you rewrite the natural log? Oh, good point. Good point. Okay. Samuel, you have any ideas to share with us? Yes, ma'am.
Don't just have smart people in there, you have to answer.
Aww.
Did you see it? I did.
Her mama did.
Sorry to interrupt. Thank you.
Samuel, tell me what you said. Let me write that down. You said let u be the whole natural log of cosine x, right? Is that what you said? Okay. And then du, if u is natural log of cosine x, then what's du? Yeah, it's 1 over cosine x times the derivative of cosine x. I think I'd have a negative there, yeah. Dx. Oh my word. Well, Sam just tried something and okay, tell me. Okay, and that's what I was addressing. Sam just tried something. He wasn't sure that letting you... it seems like thinking in terms of you has very often been the thing to do. Pick something to be you and see what happens. What occurred to Sam, and I don't know, maybe he can see farther down the road than I can because I'm kind of short-sighted. I can't see from A all the way to C. Were you able, you saw that before you started writing, didn't you? Yeah. Okay. But let's say it was me. Then I probably wouldn't have been able to see, oh, that's what I need. So I would have just written it down. Let u be something. I probably would have let u be cosine x, and I just wouldn't have gotten anywhere with that. And so then I think, well, let u be the whole natural log of cosine x. And I have to write it down and write down what du is in order to go, oh, that's exactly what I need because that tangent is sine over cosine and I can get that negative. So, let me write this down and then I'll finish that sentence. All right, two things before I finish that sentence. Number one, is that equivalent to the line above it? Is it? Not without a negative out front. Now is that equivalent to the line above it? Yes, now it is. And is it of the form, was u my cosine or my whole natural log of cosine? Okay, so what helps me is to label this u and all of that du. The labeling helps me. And I say, how do I integrate u? What's the antiderivative of it? Just u, whatever it is. F u squared. I think that maybe Cheryl, and I don't think that you're the only person feeling this way right this minute, but so far, when I was encountering calculus 2 for the first time, up until that point, I'd pretty much always known what to do. You know, there are steps. You tell me to differentiate it, I'm going to use the product rule, the quotient rule, the whatever. I don't have to guess. I can look at it and tell. Here, I'm having to guess. Now, let's try this. If this doesn't work, let's try this. The more you practice, the less you have to guess, because the more you start recognizing patterns. But in the beginning, it's literally, well, what can we do? We can't sit here and stare at it all day. So we're just going to pick something to try to let you be, and then see what happens. And if it's not right, I'm going to have to erase it and start over. And that's very uncomfortable for somebody who's always known the right thing to do. There's a life lesson there. In life, you don't always know the right thing to do. You got to sometimes just do something. Try something. Make peace with not knowing. The other advice I give you on this, it's very tempting to start thinking, if I didn't write that, I would go, I don't know how to integrate that. I don't know how to integrate that. But if I just call it you and stop looking at how ugly it is, I know how to integrate you. All right. There's the comfort is not going to come for a long time. Trust me. And I'm not there yet myself, but I'm getting there. 48. And I probably wouldn't have thought of that at first. I would have said, is there a way I can split that into two fractions? No. Can I let the denominator be the whole u? No, I'd have to have a negative cosecant cotangent in there. And it's only when I ran through all my other tools and saw that none of them worked that I would remember that very last tool in the bottom of my toolbox, which is multiply by the conjugate, by the Pythagorean conjugate. And at first, I don't know why that was helpful. It looks worse now than it did to begin with. becomes cotangent squared theta minus 1. And I might just have to have my Pythagorean identities written down at the top of my paper. Certainly I can write them down if I need it. 1 plus tangent squared equals secant squared. And 1 plus cotangent squared equals cosecant squared. And so what is cotangent squared? Oh. Wait.
Negative.
Yeah. If I remembered my Pythagorean identity wrong. 1 plus tangent squared is secant squared. I know that one's right. 1 plus cotangent squared is cosecant squared. No, it wouldn't be negative cosecant squared. Both of those would have to be negative. Let's see. That is the way to do it. I've made a mistake somewhere. Cotangent squared minus 1. Remember, I'm not. I think I was remembering that Pythagorean identity incorrectly. That's a good thing to check. But holy cow! That's cosine. That's cosine, not cotangent. That's an excellent thing to check. Luckily, all I have to do is change a few T's to S's. Great idea, Sam. That's a great thing to check.
It's like 80% of the time.
Yeah. No, that's my mistake 80% of the time. It's my mistake sometimes. Okay, that's easier to deal with. What do you think of that? The whole reason for multiplying by a Pythagorean identity is when you do, you get, by multiplying by the conjugate, you always get a Pythagorean identity. That cosine square minus 1, again, sine squared plus cosine squared is 1. So cosine square minus 1, is it positive 1 or negative 1? I mean, is it positive sign or negative sign? Yeah. If sine square plus cosine square is 1, then cosine square minus 1 is negative sine squared. I'm just going to put my negative out front. Why is that helpful? Yeah, if we can get the denominator to be a monomial, then we can split the fraction into cosine theta over sine squared plus 1 over sine squared and how is that helpful? Okay, that might be helpful. What about that first term? You wrote it as, say it again? I think I would need to put in a middle step there, just knowing my brain. Cosine over sine times 1 over sine. that right? And then I could see that that's cotangent theta, cosecant theta, plus cosecant squared theta d theta. So far, so good. What's the antiderivative? I'm going to keep that negative outside brackets. Eventually, I will probably distribute it completely. But what's the antiderivative of cotangent cosecant? What function? The derivative of it's cosecant, and then I'll figure out the negative in just a minute. But it's cosecant. When I differ, and then checking it, when I take the derivative of cosecant theta, it's negative cosecant cotangent theta. So I need another negative theta. If I take the derivative of negative cosecant theta, it's positive cosecant cotangent. And then what about this term? Function. Negative cotangent theta. Let's check it. I took the derivative of cotangent. I get cosecant squared. So the derivative of negative cotangent would be positive cosecant squared. And then if I distribute that negative, that's just cosecant theta plus cotangent theta plus a constant. I'd like to check my answer from last night on that one. 8 number 38. Yep, that's what I got last night. We have time for one more. And it is 44. The last two I had circled were 44 and 62. 62, I'm thinking if I just break that into two terms, that'll be the first step. But let's figure out 44 real quickly. Looks like it might be arcsecant if there was a way to get an x minus 1 squared inside that radical. How could I make that happen? How could I get x minus 1 squared? Yeah, just see where that goes. The square root of, I'm going to complete the square on the x's. I need to factor out a 4 from those first two terms. 4 times x squared minus 2x. I'm just going to leave myself room inside the parentheses to complete the square and then bring my plus 3. Is that equivalent to the line above it? No? What do I have to add to complete the square? Plus 1 inside the parentheses, but everything inside the parentheses is multiplied by 4. So I really haven't just added 1, I've added 4. What do I have to do to balance that? Subtract 4. And it's still equivalent to the line above it. So let's see what we have now. X minus 1 square root of 4 times x minus 1 squared minus 1 dx. And that's a darn lot like the arcsecant function. Arcsecant function, I have to have a u squared here, and I have to have a du here. So if that's my u squared, what is u?
2. 2 times x times 1.
And my a, and I'd have to have, outside the parentheses, I'd have to have a u, because it's the thing being squared. And the thing that's being squared is this. But to integrate this, I have to have u outside the radical, and to make that equivalent to the line above it, I'd have to do what?
Multiply the outside by 2.
So I'm really doing everything very carefully. I have 2 times 1 over u, and then I have u squared, and then I have a. The only other thing I need to check is du. What's du? So before I can say that's arcsecant, I need a 2 in the numerator. Can I just put that 2 back in the numerator? Would it be equivalent to the line above it if I did? Yeah, it would. That's legal because it's equivalent to the line above it. And now, sure enough, I have du over u times the square root of u squared minus a squared. And that is, still having a look at my cheat sheet, arcsecant has 1 over a, which is just 1. Arcsecant absolute value of u over a is just absolute value of u. That's what I got last night. All right. So let me tell you what I want you to try for homework. The homework for 8.1 is this. If you will do every other odd tonight, then I'll give you the odds you skipped after the test to make sure these wheels are turning, and the practice test. Every other odd and what's here, and then the practice test. All right? Monday, I will get here early, and we will do as many problems as we need to do. Tuesday, test starts at 4:30.
Wait, what?
See ya.
Is it going to be in here or
In 1:15, yeah, my college algebra. Y'all will come in and get y'all all settled, and then my college algebra folks will start coming in for their test. Whew. Fun, fun, fun.
is in a way? It's in a way.